Okay, here we go. So this is the second day homework for tonight. All right, so this is the second day of doing the parabola. We're doing a little bit of cleanup. We'll talk about what happens if it's not centered at the origin as well, too. We'll get one more table. Remember, this chapter is all about tables and your ability to use them. So last class, we introduced you those concept of the focus and the directrix. We had this formal definition right here that you wrote down that we said wasn't very useful. So we took that basic idea right there. We turned it using a proof. We turned it into a usable formula. And there were four of them, depending upon whether it opens up, down, left, or right. Okay, cool. So those are the usable formulas. That was your homework. And then finally, we talked about the latus rectum. That's the distance perpendicular through the focus to the parabola, and that distance, and we got a formula right here. So those were our latus rectum points, and the entire distance of the latus rectum was 4a. Okay, so today's task, there's three of them. I'm going to give you the graph. You're going to write the equation. We're going to talk about what happens if the parabola is not at the origin, and then lastly, I'll show you one real-world application. Okay, so the first thing is just a quick review of what we did yesterday. I'll give you the vertex and the focus and have you write the equation just to remember how that's done. So I'm going to give you those two things, the vertex and the focus, and you'll write the equation. All right, so here we go. So there's the graph. Notice I have the vertex, which is at 0, 0, and the focus is at 0, 4. This one opens up. We can tell that from the graph right there. So we go to our table, we find which one says opens up, and that would be this one. And the equation says it's x squared is equal to 4ay. The focus is equal to 0, comma a, which means that a is the value 4. So we take the equation, we let a be 4, do a little bit of simplifying there, and we get to our equation. So that one is not very challenging, right? All right, so that's a cool game. Let's do it one more time. This one's a different one. This one opens to the right. Okay, focus is 3, 0. So let's see, opens right would be the top one right there. The focus is at 3, 0. So that means that A is 3. So we take y squared is equal to 4ax. We let A be the value 3. So therefore y squared is equal to 12x. All right, so that one's both of those are kind of like the homework that we did, so it was pretty straightforward and easy. Two main questions: what happens if it's not at 0, 0? And secondly, could I do the reverse? Like if I gave you just the graph itself, could you, without the focus, could you write the equation? So those are the first two things that we're going to do. So could you do this with any points? In other words, well, there's a point right there, that green one right there. That's not the focus, that's on the parabola. Could you come up with the equation with just that value? And obviously the answer is yes, and I'll show you how it's done. All right, so if you know the vertex, you know a point, can you write the equation? You sure can. Well, let me show you how it's done. So it says write the equation of the parabola whose axis of symmetry is the x-axis. The vertex is at 0, 0, and it goes through point negative a half, comma 2. It also says find the focus and directrix. Okay, so let's see what we got. We got the vertex is at 0, 0, and we also have a point on the parabola. If I drew that right there, you have two possibilities. Either that opens up or it opens to the left. Two possibilities, because the blue dot right there is the vertex. So the only way it would go through that red dot is if it opened up or it opened to the left. And the question is, which one is it? To figure out which one it is, we get this other bit of information right here. The axis of symmetry is the x-axis. And remember, the axis of symmetry cuts the parabola in half. So if that's the axis of symmetry, it doesn't open up because that wouldn't cut it in half at all. But if it opens to the left, notice, look, it cuts it in half. So tonight for homework, they're either going to say the axis of symmetry is the x-axis, the y-axis. If this one had said the y-axis is the axis of symmetry, then it would open up. Okay, so we've established the fact that it opens to the left, and we got a table that tells us, right, which formula I should use. So for the opens left, it should be that formula. Y squared is equal to negative 4ax. And the issue is, I don't know what a is, and I can't find it out because I don't know what the focus is. But I do know I have that point, that red point right there, negative 0.52 is on the graph itself, or on the parabola itself. And remember that equation right there, y squared is equal to negative 4x, tells me all the points that make up that green curve right there. So just plug that point into that equation. All I'm doing is taking that point right there, negative half 2, plugging it into y squared is equal to negative 4ax. So the x value is 2, and the y value is negative half, and then solve for a. 2 squared is 4. Negative 4 times negative a half is 2. Divide those both sides by 2, and you get that the a value is 2. So take that a value 2, plug it into the equation, and you get negative 8x. A is 2, right? See what I did there? Okay. So that one isn't too bad. All right. We didn't finally answer all the questions because it says find the focus and directress. Well, it's sitting right there, circled in red right there. The focus is at negative a0, so a is 2, so negative 2a. And the directrix is x is equal to a, so x is equal to 2. And that's how it's done. So this just adds one little bit of complexity there, right? Figure out what a is. You get a by plugging the given point into it. All right. So maybe do that one more time. So write the equation of parabola whose axis of symmetry is the x-axis, the vertex is at 0, 0, and it goes through point 2,3. So the vertex is 0, 0. That goes through point 2,3. So this either opens to the right or it opens up. Well, we take the fact that the axis of symmetry is the x-axis. Therefore, that cuts it in half. So therefore, it must open to the right. It could open up if the axis of symmetry was the y-axis. But in this case, since it's the x-axis, it has to cut in half, the parabola. So therefore, we know it opens right. All right, so we go to our table. Opens right is the top one. Y squared is equal to 4ax. Solve for a. And we solve for a by taking the point 2, 3, that x and the y value, 2 and 3, x is 2, y is 3, plugging it into the equation. Remember the original one said y squared, so that would be the 3. 3 squared is equal to 4a times 2. Let's see, 2 times 4 is 8. 3 squared is 9. Divide both sides by 8. And you get a really ugly number, but it's okay. A is equal to 9/8. So plug 9/8 into A. Do a little bit of reducing the fraction right there, and we get 9 over 2. Okay, hopefully that one was easy as the first one. And the numbers aren't as friendly, but it's the procedure is the same. All right. Let's see, the focus and the directrix right there. So if 9/8 is A, so the focus says is A0, so 9/8 is 0, and the directrix would be x is equal to negative 9/8. Cool. Don't forget that it's going to also ask you to graph for homework. And remember, the easiest way is to use the lattice rectum points. Now, for open right, remember that's the formula, but I'm going to show you an easier way so you don't have to look at a table. You can just remember this. The total distance of the lattice rectum is 4a. So half of that would be 2a. So we simply need to find, once we find the focus, we simply need to go up or down or left or right, depending upon where the lattice rectum is. And we just simply need to go to a value of 2a, up, down, left, or right from the focus. It's going to make more sense if I show you an example. So here's your example. This is one that we just did. So we figured out that this one opens left. We also figured out the focus was at negative 2, 0. So if it opens to the left and the focus is negative 2, 0, I simply need to go up and down from the focus since it opens left to get to the lattice rectum points. So let's see, if I go up 2a from the focus, a is 2, 2a would be 4, right? So it would be 4, so 2a would be 4. If I go up 4 from that focus point, that would change the y values. And then if I go down 4 from the focus, I would wind up there, and well, there's your graph. So that makes it pretty easy to graph. Okay. The elephant in the room is, well, what happens if it's not centered at 0, 0? What happens? So all of these answers right here are where the vertex is at 0, 0. So I'm not going to prove it to you. I'm just going to give you the table itself. It is a new table, so if this one has 4, next one's going to have 4 as well too. This is a video, so I'll pause for a couple seconds and then I'll continue. But here are all the things you need to write down. New table. So these are what happens when the vertex is not at 0, 0. Well, this is what you got to use right here. Okay. So it literally took like 5 minutes for everybody to write these down. This is really critical that you don't drop a negative and you write these down exactly the way it appears. So let's see. It says write the equation of the parabola whose vertex is at negative 2, 3, so it's not centered at 0, 0, whose focus is at 0, 3, and it says then graph the equation. So we're given that the vertex is at negative 2, 3, and whose focus is at 0, 3. So if I graph that, notice it doesn't say anything about axis of symmetry. It just gives you those 2 points. The vertex is at the red dot there. And we know the focus is on the inside of the parabola. So this one, just by observation, this one must open to the right. The red is the vertex, the blue is the focus. The focus is always on the inside. So I know it opens right. Well, that's a good start. So I go to my table. These are going to be really small. You can't see them very well. But I go to the opens right one, that one right there. Okay. Well, how do I come up with the equation? Well, the equation, if you look at it, says y minus k quantity squared is equal to 4a times x minus h. I know what h and k are. H and k are the vertex, and it tells me the vertex. The vertex, the h is negative 2, k is 3, so I can plug those in. It also tells me the focus, so it says that h plus a is equal to 0, and it says k is equal to 3, just like the vertex. So I can use the fact that the vertex is at negative 2, 3. I plug that in for the h and for the k, and it was x minus h. And since h is negative 2, so x minus minus 2 would be x plus 2. And it says y minus k, and k is 3, so y minus 3. So once again, this all boils down to I got to figure out what a is. And we're going to do this exactly the way we did it before. We're going to look to the focus to find the a value. But this one's a bit more complicated because look at what it says there. It says that the x value, which is 0, is equal to h plus a, and the k value is equal to 3. And I need to solve for a. And only one of those, not k, but the h plus a has an a in it. So use that one. So I'm going to use the fact that 0, do you see what I'm circling right there? I'm circling this part. That 0 is equal to h plus a. And I know what h is. H, if you look at the vertex, h is negative 2. So I can solve that now for a. Add 2 and you get a is equal to 2. So go over to the equation. Let a be 2. 4 times 2 is 8. Therefore, there's your final equation. It does say to graph it. We're going to use the lattice rectum points for that. Remember the lattice rectum points, since this opens to the right, then the lattice rectum points would be up and down from the focus. The focus is that blue dot, and we said it's going to be 2a above or below, or left or right. In this case, it's above and below because it opens to the right. So 2 times 2 is 4, so I need to go up and down 4 from that blue dot. So if I go up 4, that's the y values. That 3 there would be 7. And if I go down, that 3 minus 4 would be negative 1. If it asks you what the points are, well, you got to do that. But if it asks you to graph it, well, then just graph those points, play connect the dots. I just went up 4 and down 4 from the focus. So if it opens right, you're going up and down. If it opens left, you're going up and down. I'm sorry, if it opens right, you're going up and down. If it opens left, you're going up and down. If it opens up, you're going left and right. And if it opens down, you're going left and right. And that's the only thing you got to think this through. Okay, cool. Do one more. So write the equation of the parabola whose vertex is at 2, negative 3, whose focus is at 2, negative 5. So the vertex is at 2, negative 3, the focus is at 2, negative 5. The blue is the red is the vertex. The blue is the focus. The focus is always on the inside, so therefore this one opens down. Think that through. The red is the vertex, the blue is the focus, so it must open down. Okay, so I'm going to go to my table, opens down at the last one. I know that the vertex is at 2, negative 3. I know the focus is at 2, negative 5. The formula for the equation says an h and a k. I know h is 2, k is negative 3. So I plug those values in. That 3 is positive because it's it's y minus k. K is negative 3. So y minus minus 3 would be y plus 3. Now to solve for a, we go to the focus. And notice this time the a is not in the x value, the a is in the y value. And it says right there, it says the y value for the focus is k minus a. So k minus a is equal to that negative 5 directly above it in red. So I set that up. So y is equal to k minus a. I know that k is the value negative 3 from the vertex. I'm just looking at what k is, negative 3. And I solve that. Add 3, negative 2. Multiply both sides by negative 1, and we get 2. So A is the 2 value. So plug 2 for that, we get -8. To graph it, we're going to once again, we're going to go to the lattice rectum points. So we're going to do 2A. Well, if A is 2, then that means 2A is 4. Since this opens down, the lattice rectum points are going to be to the left and to the right of the focus. So I need to go left 4 and right 4. Left and right affects the X values. So the blue dot is the focus. So I need to go left and right of that 2, the X value. So they'll add 4, you get 6. Subtract 4, you get -2. So those are my points. Graph those points, play connect the dots, and you're done. Hope that made sense. We'll do one real problem and call it a day. All right, remember yesterday when I said that if you took a parabola and an axis of symmetry and you spun that green curve around the axis of symmetry, you'd get a paraboloid? Remember that? Paraboloids look an awful lot like an old car headlight, and well, that's why they do look like that, because old car headlights were paraboloids. They shone a beam of light. If you put the light bulb right there at the focus, then it makes a nice column of light extending from the headlight, or spotlight in this case. All right, so let's see. It says a satellite dish is a paraboloid. It says signals that strike the dish are reflected to its focus where a radio receiver is located. If the dish is 8 feet across at its opening and 3 feet deep at its center, where's the focus? Remember, this was Abby's question of how do you find the focus if you don't know where, if all you're given is other information. So here's an example of that. Okay, we want to make this easy, so we're not going to put the vertex at anything other than 0, 0, because those are way easier formulas. So satellite dishes kind of point up. You could actually point this left, right, up, or down to solve the problem, but I'm going to point it up. So this is the basic idea. You've got a satellite dish. The opening is 8 feet wide, and it's 3 feet in depth. And we need to figure out where to put the focus. Okay, so I'm going to make this easy and just point it straight up and down, make the vertex at 0, 0, just to make my life easy. So 8 feet across, half of that would be 4. So those 2 purple dots right there are 4 to the left and right of the vertex. You see that? They're up 3 because that's the depth of the circle. So this is an open up face parabola. So to figure out the vertex, well, we simply write the equation of this. So I'm going to write the equation of this. I'm going to pick one of those points, -4, 3, or 4, 3. Obviously, I'm going to pick 4, 3, positive numbers. And I'm going to use it for the opens up formula right here. So for the opens up formula right here, in fact, you can see right here, I put the wrong table there. That should be the normal table for at 0, 0. So refer back to that, not this one. So that's the opens up table right there. We know that the A value is 3. So therefore, 4 squared is 16. 4 times 3 is 12. Divide both sides by 16. So we get 4/3. So A is 4/3. So the focus is at 0, comma A. So 0, 4/3. And well, 4/3, we could write that as a decimal. We'd have to round. We could write that as a mixed number. That would be 1 1/3. And that's in feet, by the way. Well, let's see, 1/3 of a foot would be 4 inches. So that would be 1 foot, 4 inches from the center. And that's how that one was done. And that'll be it for the class. If you have any questions, hit me up tomorrow when I see you. Good luck.